Hi everyone, I'm Dr. Surjit Singh. This is Leetcode problem number 67. It's a unique problem that showcases bitwise operations. Welcome to the video. We are given two strings that contain binary digits. We want to find the binary string that represents the sum of these two strings. First, we convert the binary string to integers. Most languages such as Python and Java have built-in functions to convert binary strings to integers and vice versa. Next, we add the two integers, and finally we convert the result back to binary string. Python function for this is int. The second argument in this function is the base. Because a and b are strings of binary digits, the base of the int function is set as 2. After addition, the format function of Python is used to convert the result back to the binary string. This becomes a one-line program. Its time complexity is of the order of m plus n, where m and n are the lengths of the input strings. The limitation of this method is the size of an int, which is usually either 32 or 64 bits, especially in Java language. Int, long, and big integer of Java all have either size or speed limitations, so Python is far better for this program. Next, we will discuss two variations of the program in which, first, binary to decimal conversion is not allowed. Second, plus operation of integers is not allowed. Let us now discuss the first variation of the problem, and for this we will follow the bit-by-bit processing in a linear approach. Consider the two strings A and B comprising of zeros and ones. Our goal is to get the string that is the sum of the binary numbers represented by these strings. Length of A is 5 and that of B is 4. We define n to be larger of the two lengths and expand the smaller string to make A and B of equal lengths by filling required number of zeros to the left of the smaller string. zfill is the Python function for this purpose. Next, we define an integer named carry and initialize it to 0 and create an empty list named output. We start processing all the digits in the reverse order in a loop, starting with the lowest order bit first. Inside the loop, we will add the carry and the two bits of A and B. Carry is 0 in the first iteration. For this purpose, we inspect the character at the ith position in A. If the character is 1, then we add 1 to carry. Similarly, we inspect the character at the ith position in B. If the character is 1, then we add 1 more to carry. Here is a handy table for decimal to binary conversion. Sum of 0, 1 and 1 is 2, and in binary form 2 is written as 1, 0, which is the present value stored in carry. Next, we split this 1, 0 into 2 bits. The integer division of carry by 2 gives us the remainder as the low order bit, that is 0, while the quotient gives us the high order bit, that is 1 in this case. We append the low order bit to output as a character, and we transfer the high order bit as the carry for the next iteration. In the next iteration, the sum of 1, 0 and 0, which is 1, is stored in carry. Division of 1 by 2 gives 0 as the quotient and 1 as the remainder. So character 1 is appended to the output and 0 becomes the carry for the next iteration. In the next iteration, the sum of the three binary digits is 1. So 1 goes to the output and 0 to the carry. In the next iteration, sum is 2, which is 1, 0 in binary. So character 0 is appended to the output and 1 is the next carry. In the last iteration, the sum is 2, that is 1, 0 in binary. So 0 is appended to the output and 1 is the final value of carry when the loop terminates. 5 bits are present in the output We now handle the final value of carry. No action is required if this value of carry is 0. So we check if the final value of the carry is 1. Yes, the final value of the carry is 1. So we append another character 1 to the output. We notice that the problem is solved except that the bits got appended to the output in the reverse order. So we apply reverse method on output to set them in the correct order and use the corrected order in the result. Finally, we join the characters present in this corrected output list to get the string and return this string as the final result. Let us now discuss the time complexities. There are n cycles of the loop and fixed amount of work is done in each cycle. So time complexity is of the order of n. Regarding the space complexity, we had set up an output list in the working memory area which had taken n plus 1 memories including the final carry. Yet again, n plus 1 memories have been used by the output string. So the space complexity is of the order of n. Another variation of the problem is in which the plus operation of integers is not allowed. This involves bit manipulation, that is performing bitwise operations on the integer data. Our computer processors are made for bit manipulation, so the processing in this case becomes very fast. Consider the same two binary numbers a and b in the string form. We use the int function to convert them to integer forms. The default base for the int function is 10, but in our case the strings are in the binary form, so we use base 2 as the second parameter in the int function. On conversion, we get variables int a and int b, and we will use these variables in bit manipulation operations. So we are showing the integers here in their binary forms. Using bit manipulation, we will add the bits of b to the bits of a till b becomes 0. So we start a loop that runs while int b is not 0. Before we go further, I want to remind you of some commonly used bitwise operations. Addition of two bits x and y is shown here. X plus y contains 2 bits. The higher order bit of x plus y is the carry bit, and the low order bit of x plus y is the sum bit. Next, we consider the bitwise and the XOR operations. AND is true if both the bits are true, while XOR is true if both the bits are different. This means that x XOR y is the lower order bit, that is the sum bit, and x and y is the higher order bit, that is the carry bit. As the plus operation is not allowed in this version of the solution, we will use the XOR and the AND operations on int a and int b to add the bits. Unlike the bit-by-bit operations in bit manipulation, all the bits of the two integers are processed simultaneously, and we get the results of XOR and AND operations for all the bits in a single operation. We know that the XOR operation gives us the sum bits, and the AND operation gives us the carry bits, which get added to the next higher order bits to their left. So in order to use the carry bits, we need to shift them left by one step and then add them to the sum bits. Now we can add the carry bits to the sum bits to get the final result. So in the next iteration, sum bits becomes the new int a and carry bit become the new int b, and we get the new values of int a and int b to be used in the next iteration. We notice that int b has not become 0 in the first iteration, so the execution enters the loop again, in which new values of sum bits and carry bits are again evaluated, which become int a and int b for the next iteration. Once again, int b is not 0, though in each iteration the number of 0 bits in it are increasing. Again we enter the loop and evaluate new values of sum bits and carry bits. which become the new values of int a and int b. Finally, we notice that int b has become 0 because all of its bits are 0 this time. So the loop terminates and int a becomes the result. Now we convert this integer to the binary string using the bin function. First two characters of the string are characters 0 and b, which indicate that the characters following them are the binary digits. So we drop the first two characters and return the string from position 2 onwards. It is possible to merge all the three statements of the while loop into a single statement. It is possible in Python because it allows assignment of the values of two variables together in one statement. This makes the execution much faster because the two temporary variables are eliminated. We will now discuss the time complexity of this solution. If m and n are the lengths of the input strings, the time complexity is of the order of m plus n, because there are in all m plus n bits that are merged with each other. The space complexity is the number of bits in the final result, which is the larger of m plus n. Hope you enjoyed the solution. This is a good example for understanding some commonly used bit manipulation techniques. Thank you for your time. If you have any questions, feel free to ping me. See you in the next video. Have a good one. Thanks.